the packets sent from my wired LAN interface, ET80, to another computer, and that are sent into my computer, I'd like to record them, save them in a file, capture them. In the same way that I'd like to record audio sometimes on my computer. How do I record audio on your computer? You can use some audio software to record audio. So on these computers, there's different software. Audacity is some audio software, and it records the audio input. Right, saves to a file. You can also record the screen. You can use some media player, or usually VLC, for example, has an option to capture, open the capture device and record the desktop, right? Some sort of screencast. So we can record inputs to our computer in the same way as recording audio and video. We can record packets. We capture packets. And then we'll look at those packets and see what's happening from observing them. How do we capture packets? Two pieces of software we'll use. One of them is Wireshark. Wireshark is a comprehensive piece of software that allows us to capture packets and view them, look at them. But another one, which is just on the command line, is called Tcp Dump. It can capture packets. It doesn't just capture TCP packets, it captures all others as well. The old, originally was focused on TCP packets, but now it covers everything. So we will use the command line program called Tcp Dump to capture packets, save them in a file, and then we will use the GUI program Wireshark to look at them. All right, it's hard to look at them with Tcp Dump. It's not so nice. So we use a combination. So let's try. We'll capture some packets. There's an example there, but we'll try. And then you'll have some tasks today, 3 tasks today to do some captures and observe some things about protocols. First, a demo. We're going to capture packets with Tcp Dump. That's the command. And which packets do I want to capture? Which network device do I want to capture from? I need to specify. So again, before that, ifconfig shows me the different interfaces I have. I have ETH0, ETH1, ETH2, LO. I want to capture on the one that's being used. Which one's the yellow cable plugged into? It's ETH0. So Tcp Dump interface ETH0. Record everything that interface ETH0 is sending or receiving. What's -n do? I've used it in other networking commands. What's it do? -n. Really, you think of it as no nicknames. With respect to addresses, show the raw addresses. Don't give me nicknames. I don't like nicknames because they can maybe confuse things sometimes. I'd prefer to see the raw addresses. So many networking commands, there's a -n option to show the raw addresses. I will use that. And let's start capturing. And it says you can't do that. You're not permitted to run Tcp Dump. You're not allowed to capture everything sent into the computer. If you could, when someone else is logged into the computer, you could run Tcp Dump and record everything they send, including all their passwords sent out to the websites. So Tcp Dump is a protected command. You need to be admin or super user to do that. So what do? Super user do. Sudo. Do it as super user. And because I'm zoomed in a lot, you can run it there. I'll just bring up another window where I'll do it. -n. And we'll need the password for student, and we run and it starts printing packets, one line per packet captured on the screen. And it's just a summary of each packet. Now, it's hard for me to read, all right? The packets are scrolling through, there's many packets there. It's hard for me to observe what's happening because it's happening so fast, there's so much information there. So, although Tcpdump records packets, it's just displaying them on the screen. So let's stop that, Control C. It shows me that there were 600 packets captured. Fine. Yours will be different, maybe. So what I want to do is, instead of print them to the screen, I'll write them to a file. And there is an option to write them to a file. You don't have to redirect. It writes a special format using -W. And I will use the extension PCAP, packet capture, as the extension. It's nice to use that extension because it's recognized by the next piece of software, Wireshark. So instead of printing on the screen, write to a file. And now it says it's listening, so it's really capturing now, and nothing's printed on the screen. It should be saving in a file. Now let me, in my other terminal, do something. Let me access a website. Access the ICT website, just download the web page. And it downloads the web page, and hopefully the packets which were sent to and from my computer to download that web page were recorded by Tcpdump. So I access the web page, go back to Tcpdump, and let's stop the capture using Control C. Print some summary stats, 711 packets captured. So what we're going to use Tcpdump to record or capture packets, and then we want to look at them, and Tcpdump's not so nice to look at them, so we'll use the GUI Wireshark. You can either type Wireshark followed by the file name, or you can open via the shark fin. And Wireshark presents by default 3 different areas to view the packets that were captured. So there's the top area, which is a list of packets. One line per packet. Everything captured is listed here. Then when you select one, the bottom 2 areas, this area shows the details of that one selected packet in some nice human-friendly form. We can zoom in on parts and look at header fields. And down the bottom, it shows the details of that packet in the computer-friendly form of, in this case, hexadecimal. Packets are just a sequence of bits. It's just that some of those bits have special meaning. Well, instead of showing the bits, we could do the bits view. If you right-click in this bottom area, I can get the bits view. If you want to really look at the binary form of the packet, you can do that. But by default, it shows a hex view, a bit shorter. This is the raw form of the packet. The middle part is the interpretation from Wireshark's perspective of what that raw form means. And that's the thing that we mainly look at, the middle part. Note down the bottom, it may be hard to see on the screen, but right down the bottom in the status bar, when you select something in the middle part, it shows you how many bytes. When I select my frame, it shows down the bottom 214 bytes. I select Ethernet, 14 bytes. IP, 20 bytes. Okay, so note the status bar shows you something about size. That's useful when we want to observe how big our packets are. First, let's look at the packet list. Packets are ordered. All right, I captured 700 packets. They're given numbers. And the first one we say was captured at time 0, and then each subsequent packet sometime later, measured in seconds. So the second packet in mine was 6 microseconds after the first one. So we have the time. That's measured in seconds relative to the very first one. Who sent it? Who received it? Source to destination. What was the application or highest layer protocol used? So that tells us about what was happening, what this packet's related to. Secure shell, the length of that packet, and some summary information. This first packet sent by me, computer 1, sent to who? Stand up if you received the first packet on my screen. Don't be shy. Anyone? Someone standing up or just leaving? Is anyone sitting at computer 27? Or we have a ghost there? Or at least put your hand up if you don't want to stand up. Okay, so this packet on my screen, you can sit down now. This was sent by my computer to computer 27. I know by the IP addresses. All right? Using secure shell, why? Note that everyone's logged into my computer. At the start, you SSH into my computer, so there are many packets going to and from my computer. Computer 27, 26, 12, 3, so this is all of your computers when you've logged into mine. Let's find my web page request, because when I captured, I accessed a website. I hope I've captured that packet. So the filter is very useful. Of those 700 packets, I don't want to have to browse through and find the ones of interest. Take some time. There are a lot of packets being sent in the background. Let's find the ones of interest using a filter. And on the slides, I give some example filters. You can try some of them. You'll work out the best ones for you. I'm going to filter and try and find HTTP and IP address equals me. Show me all the HTTP messages where the IP address, source or destination, is my computer. And I apply that filter, and now I get just 2 packets. And hopefully you can see that the first one sent by me to 10.10.6.11, going back to wget, 10.10.6.11 is the IP address for the ICT server. First one was sent from me to the web server for ICT, and the second one is sent from the web server back to me. That's what I observe here. Using HTTP, and the summary was the first one was me, my browser, saying get the page identified by /. The response was the server saying, here it is, everything's okay. And if you look in that response, you'll see that, just briefly, and you'll have a chance to do this yourself the rest of the lab today, so I'll just go through quickly. That response message was 1,418 bytes. It contained an Ethernet header. Inside that contained some source and destination addresses, some hardware addresses, an IP header. Inside that, source addresses and other fields of the IP header. Uses TCP, HTTP uses TCP, port number 80 from the web server to my web browser. In this case, it says there's 2 reassembled segments. The reason was the web page was too big to fit into one segment. It was split across 2, and they were joined together. And the HTTP header, showing some information about the web server response, and maybe the thing of interest, the line-based text data, is the web page. So the web page sent from ICT server was included in this response, and that allowed my wget program to save it in a file. So your objectives today are to learn how to capture with Tcpdump, not so hard, you've just done it, and then learn how to find information in Wireshark, right? So over the rest of the course, we will use Wireshark a number of times, and you say, capture this, and then answer some questions. So today is getting some initial experience with using Wireshark. That is, what do all these columns mean? How to interpret the packet details? How to do filters are some of the things I want you to learn today. And to learn, there are some tasks. So in the following 3 tasks, what you need to do really is capture with Tcpdump, use some application, stop the capture, open in Wireshark, and then answer some questions from what you observe in Wireshark. And I'll ask you to draw some pictures as well. So make sure you have some paper and pen or pencil to draw some pictures soon. You'll see some examples on the next 2 slides, but I'll let you do the capture first before I explain the message sequence diagram and packet diagram. But I think you've seen them before, so not too hard. So to the first task. Let's use netcat, which you know how to use, with your friend. Start a capture, start Tcpdump. Use netcat, server, client, send some hello messages to each other. Stop your capture and find the packets which were sent in Wireshark. And to make it, do it first in the normal netcat mode, which will actually use TCP, and if you can do that, then you can try it again, but use netcat in UDP mode. All right, so the first task, start Tcpdump, use netcat with your friend. Both of you can use Tcpdump in one terminal, use netcat in another terminal. Once you've sent some messages to each other, stop Tcpdump, open in Wireshark, and just find the packets related to netcat. You need to search through and maybe find a filter. So I'm going to try and capture the netcat packets. So I'll start Tcpdump. Start the capture, and then on computer 14 start a server, listen on port 1, 2, 3, 4, 5, and then start my client, connect to computer 14, port 1, 2, 3, 4, 5, send my messages, and now we'll see that in the capture. So I just send some packets between computer 1 and 14, stop my capture, and now open that in Wireshark and have a look. And remember, it's useful to disable name resolution. Then you won't see the nicknames, you'll see the raw addresses. And I see there are a lot of packets. Let's try and find, how do I filter on packets? There are different ways to filter. Port numbers can be filtered. IP addresses, protocols. So it's the slides show some different filters that you can use. All right, so you can filter by protocol if you know the IP address. TCP has its port number. Tcp.port equals 1, 2, 3, 4, 5, because I know I listened on port 1, 2, 3, 4, 5. So that's one way. And I find these packets, and I'll just turn off color coding here. The time, let's hide that for now. Even the source and destination. So computer 1 is me, computer 14 was the other computer running the netcat server. So the first message is sent from me to the server and then back. What are these messages? Well, we see the first three, me to the server, back, and then a third one from me to the server. These are TCP messages, and the way that TCP works is before we send any data, we set up a connection. We synchronize the two endpoints. And the way to synchronize two endpoints in TCP is to send some synchronized packets. So they're TCP segments, but there's a flag set called SYN to synchronize. So the way that it normally works is that I send something to the server saying, I want to synchronize with you, the first SYN. The server sends back an ACK saying, okay, and the server also sends a synchronized message to me. And it combines them together into one packet. That's why we have a SYN and an ACK together. And the third one is me sending the server acknowledging its SYN message. Roughly, we can try and draw that. If we try and draw that on the screen, if I can get it to work. There's me and computer 14. This is our message sequence diagram. And the first message is the SYN message sent from computer 1 to computer 14. So this is what we're going to draw is called the message sequence diagram, try to capture the messages. And then there's the SYN ACK that comes back. And then the third ACK. This is TCP setting up the connection. So the way that TCP works is before we send data, we set up a connection. And the typical way is SYN, SYN-ACK, ACK. They're trying to synchronize sequence numbers and synchronize the two entities so they're ready for data transfer from my computer 1 to 14. You should write the IP address here to be more precise. Okay, so I've just written the computer number. Then the next message we see I send something to the server, computer 14. What do I send? In TCP, it's called a push message. And push usually means it contains data. It's saying, here's some data, push it to the application at the other side as soon as possible. And if we look inside that one message, the fourth one here, we actually see the data. Down the bottom we see it contains the word that I typed in, the words I typed in. So hello Steve. So this is the data message coming from client to server. And then the next one is an ACK. There's no data in this one. It's just an ACK saying thanks for the data. So we could draw that. So the fourth message is the data. And then there's an ACK that comes back. So I don't write PSH, ACK, because what it really means to me, it's data. And the data was whatever the message I typed in. And there's some more messages after that. I could draw them if I like, depends how many you sent. But that's the important parts of what we see in that message transfer, we see a connection set up, and then the data transfer. And that keeps going. If you're lucky, you may see a connection close at the end. You may see some fin segments to finish the connection, but you may not see them. So this is what we call a message sequence diagram, and I'd like you to draw them for each time we ask you to capture packets, so for each of the 3 tasks today. Don't draw things that you don't understand. That is, don't write names here which are exactly like on Wireshark. Interpret to what it really means, or simplify it. So I don't write PSH, ACK, I just write data, because I know it's really the data. Okay? And the next one's the ACK. I could add up more details, but that's enough in the context of this question. You could add sequence numbers if you like, but that's sufficient to see the types of messages. Then the other type of diagram is to draw maybe 1 or 2 of the packets in detail. Let's say focus on the data packet. Let's zoom in on that one data packet and try and draw that. This one data packet is this 4th one in my capture. If I double click, it shows me that details of that one data packet. And the way to interpret the Wireshark information, note these rows here. That tells us the basic structure of the packet, or a frame is a more precise name. The entire frame is 78 bytes long. The frame is made up of an Ethernet header, an IP header, a TCP header, and 12 bytes of data. So if I want to draw this frame, I would try and illustrate that there's an Ethernet header, an IP header, TCP, and data. Let's try and draw that, and quite simply just illustrate it as a packet diagram. And you've seen in lectures how we draw this. Some form of rectangle to illustrate that one packet. And what do we have? Split it into 4 chunks. Doesn't have to be to scale. There's an Ethernet header. If I can get this to spell correctly. Ethernet, IP. What was next? TCP. And then the data. And all of this was our one large frame. Total size. How big was the Ethernet header? So that's my frame. That's how I say to draw the packet diagram. Identify the headers. And the other useful thing is the size of each. And it's easy to see the size when you click on one of the rows, and I'll go back to the main window in Wireshark. When I click on the Ethernet row, if you look down the bottom in the status bar, it shows you the size of that Ethernet header, 14 bytes. IP, right down the bottom, 20 bytes. TCP, 32 bytes. Data, 12. So we write the sizes on the packet as well. So the total frame size, 78 bytes. when we select it, or we see here, captured 78 bytes. That's the entire frame, but it's split into an Ethernet header, IP, TCP, data. So that's how we can visualize it. The entire frame is 78 bytes. The individual headers, or the chunks, are listed there. So that's the basic way to draw a packet diagram. Sometimes it's useful to add a few details. What's inside the headers? In Wireshark, what's inside the headers is shown when we, again, zoom in on a particular packet. We can expand and see the Ethernet header contains a destination address, source, and the type, IP packet. The IP header contains a number of different fields, including source and destination. TCP, sequence numbers, ACK numbers, flags, port numbers. And the data, well, the data is just the data that I sent. So sometimes it's useful on the packet diagram to draw the values of important fields. Maybe the addresses are useful. For example, I can draw the source and destination IP addresses. Now, you don't need to draw all fields on the packet, and sometimes you can get away with drawing none, but sometimes if there's a key value of importance, highlight it on your diagram. Addresses are usually important, port numbers. Sometimes there's a particular field in a question that will arise. So whenever you capture, whenever we give you tasks of capturing, draw these two types of diagrams. You don't need to draw every packet, maybe the main ones, like I chose the data packet. The ACK packet's not very interesting, the data's of interest. And in the frame exchange, the message sequence diagram, you don't have to draw every single packet captured. Again, just select the main ones, or a sample of the main ones. So that's your task for today. The first, so you draw a message sequence diagram, a packet diagram. There are better drawn ones there. You should have captured with NC. You should quickly try, even if you don't capture, try to use NC in UDP mode. All right, try to use NC in UDP mode. You don't need to capture it. Then we'll have a break. And then at 2:40, you can continue on with task 2 and 3. So just keep going with them. Task 2 is to use ping, capture, look in Wireshark, answer some questions. Task 3, access a website while capturing, look in Wireshark, answer some questions. With the aim of learning about how to use Wireshark and Tcp Dump today.